Swiftmeisters and Data Divas, I'm Professor Gallagher, and in this lesson we will continue to work with the ultra-fabulous SwiftData extensions to SwiftUI. Specifically, we'll cover how we can use a picker view to interactively make changes to values created using a query property wrapper so that we can reload data that's sorted, ordered, or filtered. So let's sort out these techniques for some more big learning. So Swift Scholars, we're continuing in our to-do list app. If you're new here, welcome. You might want to start from earlier lessons in the playlist so you can see how we got here. And before we start, I also want to give a shout out to some other folks in the SwiftUI community who helped answer some of my initial questions. Flo Writes Code and Stuart Lynch. They both have Swifty YouTube channels, and I highly recommend both for additional big learning. Their sauce is always awesome. Keep dropping knowledge, you exceptional Swifters. And also, Stack Overflow user Pixel Shaper offered some additional insights that I found helpful. Big thanks to him as well. Now let's begin cooking in the to-do view. This is the first view loaded by the app, and it shows the results of what's saved in SwiftData. And the first thing we'll do is create an enum with options that will display in the picker view. Now, if I was working on a more complex app with the team, I'd likely break this out as a separate file so it's easier to find. But for this lesson, I'm going to start by keeping everything in the to-do list view. I'm going to write this just above the struct. In this learning example, I think it'll be easier to scroll up and down to reference the code. So I'm going to write enum, I'll call this sort option, upper camel case, colon, conform to string so that I can add raw values, and case iterable so that I can loop through all of the values using a for each. I'll set my cases as case as entered equals the string as entered, case alphabetical equals a string a-z, case chronological equals the string date, and case completed equals the string not done. Now our picker view is going to need a state variable to hold its selection, so in the to-do list view, I'll add @state private var, call this sort selection lower camel case colon, this is of type sort option, the enum we just created, and I'll initially set this equal to dot as entered, meaning we'll show the data as it was entered, unsorted, and not filtered. Now to set up a segmented picker at the bottom toolbar, I'll add a new toolbar item between my toolbar modifier curlies. I'll select the toolbar item with placement and content and press return. My placement will be bottom bar, and I'll tab and press return for trailing closure, and here I'll add a picker view, selecting the option with title, selection, and content. The title key doesn't show up in the segmented control in iOS, so I'll just pass an empty string in here. My selector is bindings, so that's going to be $sort selection, the state variable we just created, tab and return, and for our content, we're going to use a for each to show all the options in our enum, so we're going to select the for each option with data ID and content. The data we're iterating through is sort option, upper camel case, that's the enum that we created above, and to show all cases, we'll say .all cases. Tab over to ID, that's \self, tab over to content, press return, and I'll call the option that we're showing sort order, lower camel case. Inside, we'll simply add a text view passing in sort order .raw value. That's going to show the string associated with that case. The default picker isn't what we want, so after the closing curly for the picker view, we'll add .picker style passing in .segmented. Now our first step is going to be to break out our query and the views the query displays. This will be our list and for each statements here into their own separate view. So we'll need to include the query value and the model context in that new view, since our access to SwiftData now happens in this new view, and by breaking this out into a separate view, when we call the view, we're going to be able to set up a new query and pass in the sort selection so that we can initialize our query and set that up so that it shows either as entered, sorted alphabetically, by date, filtering out just the values that are not done. So let's set this up. So I'm going to bring the list style over to my new view, so I'm just going to cut this out and paste it at the top of my list modifier so that I can cut these out together. But first, let's create the view that's going to hold this list content. So between my to-do list view and my enum, again, I'm putting these all in the same file, I'll create the new view, it's always a struct, and I'll call this, how about sorted to-do list, upper camel case, colon, and as I start to type the word view, code completion offers to fill out the standard view, so I'll tab accept. Looking good. And I'm going to go back to my to-do list view. I'm going to highlight the entire list along with the first list style modifier, cut that out. Now instead I want to call my new view from this spot, so I'm going to enter sorted to-do list. And back in the body of sorted to-do list, I'm going to paste in the content I just cut out. Now the query property that is the variable to-dos that reads in our list of to-dos from SwiftData is going to be in our new view. And to use the query property, our data also needs to refer to the model context. So I'm going to highlight and cut out these two lines and paste them into our new sorted to-do list view just below the body property. Next, I want to pass the sort that we select from our picker view. Remember, we have that in our sort selection state value. And I want to pass that into the sorted to-do list view that we just created. So up in that view, I'm going to add a property, and I'll set this up as let sort selection sort option. That's our enum type. And it's an uninitialized constant. It can be a constant since this value won't change, and it's uninitialized so that this view is always going to want us to pass this value in so that it can create the view. Now, it's absolutely possible to add attributes to our query declaration, and you can see this in Apple's SwiftData documentation. There are initializers that accept a sort order. You can filter on a predicate, so passing in a closure. And to give you some examples of how we'd set this up, and these query lines are all single line statements. They might look like they're on multiple lines just so you can view them side by side. But a SwiftData query created with no additional parameters will show data in the order in which it was entered. You can add a sort property to query, passing in \property name for the model property that you want to sort on. Here we're sorting on the to-do items in alphabetical order. In this example, the item is the name of the to-do that you see here, D&D, Learn Swift, wine tasting. Now, if you want to change the sort order, you can add an order parameter. .reversed will show things in reversed alphabetical order. And you can filter by passing in # predicate, and that takes a closure that you want to filter on, just like you'd set up a closure in conventional Swift. So here, this closure will only show to-do elements where the isCompleted property is equal to false. Now here's the tricky part. If you option click on the to-dos variable, you'll see that it's a get-only property. That means that we can't set it equal to anything after it's been created. Try to do something like this where we update to-dos with new query values, and it's not allowed. So this leaves me wondering, with a professorial beard stroke, how do we interactively add or remove attributes to create a query if it's get only? Or put another way, how can I query data based on the picker selection that I send to the view? Well, one thing that we can do is we can add an initializer to the view, and this can include a different query initialization based on the sort order that we pass into the view. Now, we won't be able to update the query options after they're created, but since sort order is a state value, whenever we tap on a new value in the picker view, the old sorted to-do list is destroyed and the new one is recreated, reinitializing the view based on the sort order that we pass in. Now, here's how we do this in code. So this here is the initializer that we're going to add to our sorted to-do list view. Now it runs when this view is created or recreated, and this will happen anytime the sort selection is updated when we click on the picker view, since the sort selection is a state value. It's a state here, not here, but this view will be redrawn since this state value here is in the call to set up our sorted to-do list in our navigation stack. Now what's going on with the initializer? Well, query is a property wrapper, and without getting too far under the hood, this underscore in front of the same name we use for our variable in our property wrapper will let us initialize our query in our init function. And we're selecting the appropriate query setup in this switch case statement here based on the sort selection that we pass into the view. Now, if you're curious, the underscore to-dos actually refers to a value synthesized by the property wrapper feature. And if you want to dive deeper into more advanced Swift, there's a discussion of property wrappers and how they work in the section of the Swift language guide at swift.org, but frankly, at this stage in our course, going into how this works probably isn't necessary. Just know that you can use the underscore value to initialize our property wrappers as part of the view's init function. Remember, we recreate and reinitialize this view each time a picker value is tapped and the sorted to-do list value is recreated. And depending on the value that we pass in, we'll choose whichever query initialization is appropriate for the selected sort option. Very cool, very reproducible in other projects, so let's code this up. So we'll create the view's initializer just like we do an initializer for, say, a class. This initializer for the view is called when the view is first created, and we'll use the keyword init, and between parens we'll pass in our value sort selection, which is of type sort option. And in between the curlies, we'll set the sort selection constant defined up here, which is self, referring to the current view, dot sort selection equal to the sort selection value that we pass in. Then below this, we'll enter our switch case statement with switch self.sortSelection, but we can see as I'm starting to type sort selection, code completion recognizes what I'm doing. Now, code completion should be autofilling cases in for this switch case statement. Mine isn't, probably yours is, but I'll fill them in quickly here. And here are all of the cases, and since the enum sort option is exhaustive, no need for a default case. So for the as entered case, we want to create a query and read the data with no ordering, just as the data was entered. We can actually initialize this by referring to the synthesized value underscore to-dos equals query, open and close parens. Now for the alphabetical case, we'll say underscore to-dos equals query, and I'll choose the option with sort and animation. Now sort wants a key path. The way we write this out is simply backslash. If I had multiple models, I could enter the model name here, but I only have one model, so I can just say dot for the properties of that model, and I'm going to select dot item. I'll also tab over for animation, and sometimes animations do something. Actually, in the case of the query, at least at this time, I'm not seeing any animations on initialization, but you can enter dot to see the different animations to work with. I'm going to select default, but again, we're not going to see anything. But feel free to try out these animations in different contexts. It should work under some circumstances. Now for the chronological case, underscore to-dos equal query, select the option with sort, and this time we'll pass in backslash dot due date. And for completed, I'm going to show you how we can filter out a subset of results. Now the syntax for this is a bit more opaque. We need to say underscore to-dos equals query, and if I start to type in the word filter, highlight this parameter, press enter, and the filter wants something called a predicate. Now predicate is actually a Swift macro. We discussed Swift macros in our previous video. Apple SwiftUI frameworks have lots of pre-built macros that have lots of hidden code, making things very easy for us. And when you use a macro that's not attached to a declaration, before we were using a macro as @model, here we're going to put a number sign before the macro's name. So we just enter number sign or pound sign, capital P predicate, and then we pass in here for this macro to do its thing is just a closure. And this is going to be just like a closure that we would use in a Swift filter higher order function. So we'll just say between curlies, $0, which says go through all of the elements that we're querying one by one, dot is completed, look for the is completed property in each element, double equal sign to check to see if the element's property equals false. That'll filter the value in. So only values with is completed equals false will show. Those are the items with an unchecked box to the left. And that's all we need to do to set up the initialization to get our interactive query selection working. But we still need to go down here and update our call to sorted to-do list. The view now wants a sort selection to be passed in. So we'll enter the sort selection, which is just sort selection, which we set up using the picker view. And we see the app is up and running. So the default is these values are shown as entered. Let's click on A to Z and look at that. Sweet sassy SQL databases, we've got our elements sorted alphabetically. Now let's click on date and oh, look at that. Now we're sorted by date and time. Looking good. Not done filters out any items that are already completed, and if you click an items completed checkbox while this option is selected in the picker view, that item no longer shows, but if you click back on another picker item, you'll see it's still there, and the checkbox is properly checked. Legendary. So you can click on any of these options down here, and remember, each time you click on this, the picker view updates the state variable sort selection, which triggers a recreation of our view. That's the sorted to-do list. So we have some interactivity in terms of the query values we are showing using SwiftData. Nice! And so sorry friends, I'm just now noticing that I didn't reformat my indents on the switch case, so I'm going to highlight this subset of my code and type Control-I, and the indents are fixed. And as I pointed out in here, this animation default really isn't doing anything, but why don't we get rid of this, and I want to show you that you also have an option to pass in an order value to your query. So instead of A to Z, let's order this in reverse alphabetical order, Z to A. I'm going to enter order, colon, and if I press a dot in here, I can do forward or reversed. Let's select reverse. This should do reverse alphabetical order. So just to keep our UI consistent, I'll Command F to search for A-Z and change that to Z-A. And I will point out that I might have misclassified the as entered area. Technically, SwiftData shows unsorted data results in an indeterminate order. That order might even change. Now, based on the limited amount of testing I've done with this app, it seems like the changes are far more frequent in the preview than what I'm seeing in the simulator or when running on my iPhone. To be most correct, I should probably change as entered to unordered, or add a timestamp for the time an order was entered and sort on that. I'll leave that up to you if you want to fix it, but I'll click on Z to A, and we see now that we're ordered in reverse alphabetical order. Nice! So you can click through the different sort and filter options. Let's quickly head back to our code and undo the alphabetical order so that it's A to Z, and I'll also get rid of my reversed order option. And just to verify, why don't we run in our simulator, since this is where our Swift data will persist and be saved, as opposed to the preview, which reloads our mock data every time our app is restarted. So play to build and run, and say it with me. Hammer time! That's a celebration of successful code.
Stop. Hammer time!
And we see our error-free app, our launch screen, and this is data that I entered earlier when experimenting with this simulator. And again, remember that the data that you see is specific to the simulator, and that means both the iOS device that you select and the operating system that the simulator is using. So if you simulate an iOS 16 Pro, but on an earlier version of iOS as well as a later version of iOS, that's two separate sets of data that you've got on two different simulators. Now, we haven't saved anything to the cloud. We'll learn a technique for that later. So the data you've got in the simulator is going to be different than you have on your device, and it's not synced across devices. Also, if you ever want to clear out the data in your app, which can be very useful if you ever make a change to the underlying data in your model, and you want to make sure that you don't have any errors when rerunning data and possibly trying to read in what is now misformatted data, you can simply long press on the app in the simulator or on your device, delete it, and then when you rerun, the app will reinstall with no data at all, and you can re-enter your data from scratch. So my data in this simulator looks great. Clicking the picker option A to Z sorts alphabetically. By date has the items sorted by date. Not done only shows those items where the is completed flag is false. And again, clicking the check mark in not done will filter out those selected items, immediately removing them from the list. But if you go back and click as entered, which really should be labeled unsorted, we can see that those items are there with their check marks. So feel free to experiment more with this if you'd like, but hopefully everything's working great for you. Hopefully you found learning to get interactivity from your queries to be useful. We also learned to use the underscore and the property name to initialize a property wrapper. If you like this, please take a fraction of a second to like the video. A subscribe helps even more, and comments posted also help surface the video in YouTube's algorithm. I really appreciate you spending time with me. Now continue to hack.